Section 7.5 talks about doing conversions between the metric system and the U.S. customary system. So once again, we're given a table that gives us approximate conversions between these two. You'll notice that most of the equal signs, with the exception of 2.54 centimeters being equal to 1 inch, all of the rest of them are wavy, meaning that they have rounded it off to the closest hundredth, so you're getting an approximate equivalency. So to do these conversions, we're going to be using the same unit fractions that we've used in the previous 4 sections. A handheld leaf blower weighs 4 kilograms. To convert that to pounds, I'm going to come over here to the weight and discover that 1 pound is approximately equal to 45 hundredths of a kilogram. So on my calculator, I want to take 4 and divide it by 0.45. The answer I get is 8.8 that repeats forever, and the directions up here said to round to the nearest tenth, so 8.8 repeating would round to 8.9 approximate pounds. Diana bought a 20-inch LCD monitor for her computer. To convert that number into centimeters, I write the 20 inches over 1. Look on my chart to see how centimeters compare to inches. This is a unit of length, so I'm going to use that conversion right there. 2.54 centimeters is the equivalent of 1 inch. So my multiplication is 20 times 2.54 for a total of 50.8 centimeters. And since this conversion is an exact conversion, we don't have to do the wavy line. It is exactly 50.8 centimeters. One more of this type. In Berlin in 2009, Usain Bolt of Jamaica set the world record for the fastest 100-meter race by completing the race in just 9.58 seconds. So knowing how that 100 meters is run in 9.5 seconds is not really a conversion or a rate of speed that we're used to thinking in. So we're going to convert this into terms of miles per hour so we can get an idea of just how fast Mr. Bolt is capable of running. So this is going to take quite a few unit fractions because you can see that we have to do a conversion from meters into miles and also convert from seconds into hours. So I'm going to start with my initial ratio, which has 9.58 seconds as my denominator and 100 meters as my numerator. Because we want the final answer to come out in miles per hour, we want to start with our distance on the top and our time on the bottom. So we're going to do 100 meters per 9.58 seconds. Then I think I'll get rid of the time conversion first. So by putting seconds on top and minutes down here, and then minutes on top and hours on the bottom. Now I'm into meters per hour. And then I also need a conversion because my table only gives me meters to yards. I want to convert to kilometers first and then to miles. So I'm going to put that meters on the bottom and change it into kilometers using that unit fraction that's just the metric unit fraction, and then do one final conversion to get rid of the kilometers and change it to miles. So first let's check to make sure that our units are going to come out the way we want them to. So this meter cancels out with this meter and this kilometer with this kilometer, leaving me with miles as my final unit of distance. The seconds will cancel out, the minutes will cancel out, leaving the hours remaining. So my final unit of time will be miles per hour. Now all I need to do is fill in the blanks for those conversions and then multiply. Well, there are 60 seconds in 1 minute and 60 minutes in 1 hour. And there are 1,000 meters in a kilometer, and according to my chart, there is 1.61 kilometers in a mile. So multiplying my numerator through, I get 360,000, and multiplying the denominator, gives me 15,423.8. Then my final step is to do that division. And the answer that I get is 23.340, and it continues on. So we're going to round that off to about 23.3 miles per hour. That is pretty darn fast.